So the next topic that we are going to discuss is structure of OS. So in structure of OS there are different types, like evolution of any system starting from the basic to the present one. We shall see the structures that has evolved from earlier days to the present. So at the first turn, while we were using this MS-DOS operating system, the structure that has been prevailing is simple structure. So in this structure, as we see here, the ROM, BIOS, and device drivers, these constitute the hardware that is present at the bottommost level, and the application program is present in the top level. And below the application program, we can see the resident system programs and MS-DOS device drivers. So in this structure, the interfaces and also the level of functionalities are not well separated, because the application programs they are able to access the IO routines, and write, and they can write directly to the disk drivers. So application programs can access the base software directly without passing through any other layers, because when we see here, application programs can access the resident system programs, and also it can access directly the hardware, underlying hardware. And in turn, resident programs are able to access MS-DOS device drivers. They can also indirectly, directly they can access the hardware. So all layers of the structure, simple structure, they have the access to this base hardware. So this freedom, it may cause vulnerability, and if suppose any malicious program runs in the application level, it will cause the entire system to crash. So this will lead to a heavy failure. So this is not well protected. Hence, this type of system simple structure, that is MS-DOS, it is written on Intel 8085 microprocessor. So this is of not that much protection. It does not give that much protection. So the next structure is the monolithic structure. So the monolithic structure, the name itself, it indicates that monolithic, in a sense, the entire uh, the entire kernel functionalities are bound together, put together into a single mono. So single pack. That is what this monolithic means. So too many functions are packed together to represent a kernel, and this functionality, this makes the implementation too complex, and also the maintenance becomes very difficult. So to make a small change in these functionalities, if suppose we have to add some functionality or we need to remove some functionality, we need to make changes in all throughout this entire kernel, because this base represents the hardware, and above the hardware presents the kernel, and these are the compilers, that is application level programs are present here to which the user interact. So if suppose we want to make a small change in the functionality, this entire monolithic structure, it has to get disturbed, and we need to make that change. So this type of monolithic structure, it exists in the Unix operating system. So in order to overcome this disadvantage, we are going for the next structure, which is the layered structure. So layered structure, instead of packing every functionality into one pack, as we have seen in this monolithic structure, here every function is disintegrated into different layers. So to solve all these disadvantages which we have seen previously, the OS is divided into number of layers. So if there is an issue in one layer, that particular layer alone, it can be updated. So we don't want to disturb the rest of the other layers. The issue in deciding and defining which layer should be put up the which layer, so that is the great question here. Because a particular layer, it can access the functionalities of the layers which is only residing below it. So for example, if we want to deal with some backing storage, so definitely the layer below the layer of that particular layer, it should be present below the layer of memory management. Only then we can deal with the functionalities of storage components. So that is a great disadvantage here, because only the layers which are present above will be able to access the layers which are present below them. So it is definitely a con here. So maybe not efficient as other structures, because when one layer it has to access the other layer below it, it has to request to that layer, it has send a request to that layer, and that request has to pass through all the other layers below it. So that is also one disadvantage. For example, if suppose this user application it wants to get access to this IO access, which is IO access in a sense, definitely it should be provided by this hardware which is present in the core. Okay, so this from the nth layer the message must pass to for access of that input and output components to this layer 0. So definitely it has to pass through all the layers below it, and it has to access this hardware. So one advantage of this layer approach is protection. What we have missed in the monolithic structure, that can be achieved here. The protection can be protection of this hardware layer, it can be achieved here, because the components of the functionalities of each layer is separated from each other, and if there is any problem with one layer, that alone can be accessed, that alone can be repaired. But whereas in monolithic structure it is not possible. So like the simple structure, the user program it cannot directly access the hardware below it, because it has to the message has to pass through all the layers to reach the hardware. So these are the advantages, but in case of disadvantage, that message has to pass through all the layers. So that is one that it is highly time complex, and in order to overcome these cons, we are going for the next structure, which is a microkernel structure. And in microkernel structure, all the necessary components of the kernel, that alone is packed into this microkernel. The term micro itself means that micro, very small. So the kernel is too small, and whatever is necessary and required, the most important components alone of the kernel are packed together into one pack, not that like that of the monolithic structure. In monolithic structure, all the services and the functionalities are packed into the kernel structure, but here one and only the important components are alone packed together as a kernel, as a separate kernel. The other functionalities are implemented as system programs or user level programs. So this microkernel it provides a communication whenever, if suppose a client program wants to access to that kernel component, it will send a system call, and at that time this microkernel it will provide the communication between the client programs, and these services are implemented as a system programs through message passing. But whenever there occurs a communication can happen only through the means of message passing. So always there will be a communication overhead. So because of this it is highly complex, but when compared to the monolithic structure, the microkernel is composed of only the required components. So that is one advantage. But in case of monolithic structure, when client program needs a service, it must ask directly to the kernel. Whereas in this approach, the client program, when making a request to the kernel it just provides a communication between the client program and the system level programs, and by means of message passing. So here the monolithic structures disadvantage it is overcome when program is executing in the user mode, because these are happening in the user mode, and this can happen only in the kernel mode. So in case of user mode, if suppose any crash happens, that is not it does not lead to a big problem. But in case of kernel mode, if it happens, the entire system will get crash. So here most of the services are only one or run they can run only in the user mode. So in that case, a higher level of security is provided in case of microkernel structure. So by this way we will overcome the disadvantages which are present in the monolithic structure and also in the layered structure. So since the communication must be done via the message passing, there could be a system overhead. All the pros and the cons we have discussed for the previous structures. The cons of all the other structures, they are overcome by this modular structure, and this modular structure is now being used in maximum number of operating systems. So in modular structure, there will be a core kernel present. As shown here, there will be a core kernel at the center, and all the other functionalities are separately present as modules. So these functionalities can be loaded dynamically whenever it is required. So which is this type of functionality is you can relate to this type of structure, which is similar to that of a layered approach, because there also each functionality is separated into separate layers. So here each module is separate, but which module wants to communicate with that alone can be communicating with the kernel. So it won't disturb the other modules. So which needs to communicate, that alone can communicate with the kernel. It does not disturb the other modules which are prevailing. So there will be an independent communication through the core kernel. So similar to the microkernel approach, the core kernel, it has only the core functionalities. So it will not have all the functionalities, only the necessary functionality is present in the core kernel, whereas the others are loaded whenever needed. So here the other functionalities are directly loaded into the core kernel as and when required, and one and only when it is needed. So no need for message passing. So in that case, definitely that the overhead of the system will be completely reduced. So in this way, the disadvantages of the previous structures and the advantages, that is the pros of the previous structures, are combined together into the modular structure, and that is why this type of structure is prevailing in most of the operating systems which are in use today. So with this, we are coming to the end of the structure of OS topic, and we can see to the next topic in the next lecture. Thank you.